Welcome everybody. So we are starting the week number 3 now. So in this week we are going to talk about acids and bases, and also we will be talking about some biology. And in the biology we will be talking about the cells. So we are going to take the tour of the cell. So we are going to go inside the cell and we are going to see what are the different organelles inside the cell, and we will also see what kind of cells we have. So let's do the chemistry part first. So it's about acids and bases. So let me open the slideshow. So first of all, the first question is, what are acids? So acids, basically they have some properties. So first of all, they are sour in taste, and they change the color of certain materials like the litmus paper. You must have heard about the litmus paper. It turns the color, like if you have a litmus paper and you add that litmus paper to acid, the color of litmus paper will turn to red. Now what is the litmus paper? Litmus paper is basically an acid base indicator, which means it tells us whether the solution is acid or base. Now this litmus paper is basically is made of a dye, which is a acid and base indicator. So this is very important property of acids, that it turns the litmus paper to red. And these acids, they react with some metals like magnesium, zinc, and when these metals, they react with the acids, they release hydrogen gas. So this is another property of acids. And when these acids, so we have acids, another thing we have is the bases. So we'll talk about bases also. But when these acids and bases, they are like they combine, they're going to neutralize each other, and that results in the formation of water and the salts. So you find acids, they are in your daily life, like all the citrus fruits you eat, like lemon, oranges, all these are called citrus fruits. And why they're called citrus fruits? Because they have an acid called citric acid in them. Vinegar is we use in the kitchen. When we make a lot of dishes, we add vinegar because we need little, we need little sour taste to our dish. We add vinegar. And what is vinegar? It's basically diluted acetic acid. Then all the drinks we drink all the time, the sodas, they have carbonic acid in them. And some of the stings or bites of some insects, they contain formic acid. Now in our stomach cells, they release an acid called hydrochloric acid, and that helps in the digestion of the food. Then lactic acid, it is found in sour milk, sauerkraut and pickles, and it gives tart taste to the yogurt. So we have acids all around us. We have acid in our body, inside our stomach, in our body. We use the acids in our kitchen. So acids are around us. Now let's talk about what are bases. Now bases, they have bitter taste, so the taste is bitter. And when you take the litmus paper and add to a base, that litmus paper will turn to blue. So this is an indication that the solution is a base. So if you have two solutions and you want to see whether it is an acid or base, what you're going to do, you're going to take the litmus paper and add to the solution, and on the basis of the color it gets, you can detect whether it's acid or base. Again, if you have an acid and you add the base to it, you combine acids and bases, they neutralize each other, forming water and salts. Slippery on the skin, caustic action, converting tissue into soluble material. So this is one of the very important property of the bases, that they can dissolve all the organic material into it. So that is called the caustic action. Okay, so some of the common bases around us: sodium hydroxide, potassium hydroxide. Now sodium hydroxide and potassium hydroxide are used in drain cleaners. They open plugged drains because of their caustic action. turning grease, hair, and other organic plugs into soap and other soluble substances that are washed away. So this is one of the very important property of these bases, which is called the caustic effect, which means they can dissolve all the organic materials. So all your hair and everything, whatever is in your drains, it's clogging it. You add the base, it's going to dissolve it, and then this is the way your drains get opened. Okay, now let's see chemically what an acid is. Now acid is that substance which gives protons. So any substance which is a donor of protons is called an acid. So acid is a proton donor when dissolved in water. Now what is a proton? Proton is a subatomic particle and it is positively charged, if you remember from your last lecture. Now if you think about hydrogen atom, so hydrogen atom has one electron and one proton. So if the hydrogen atom, it gives the one, so hydrogen atom has one electron, one proton, and if that hydrogen atom gives away its electron, then it is a hydrogen ion. You remember from the last lecture when we talked about the chemical bonding. So these atoms, they can lose or gain electrons. So hydrogen atom has one electron, one proton. So if this hydrogen atom loses that single electron which it possesses, then it becomes a ion. And what charge it will be going to have when it loses its electron? It will be positive charge, because it's losing the electron, because it's losing the negative charge. Okay, so hydrogen ion, when it has lost one electron, it becomes a hydrogen ion. So this hydrogen ion has now only one proton, because it has already lost its electron, and hydrogen atom has only one electron. So hydrogen ion can also be called a proton, because hydrogen ion has only one proton. So we can also define acid as that substance which is a proton donor or which is a donor of the hydrogen ions, because hydrogen ions or protons means the same thing. Base. Now what is a base? Base is something which is a proton acceptor. So when you take the base and dissolve in water, if it accepts the hydrogen ions or protons, it's the base. So proton or hydrogen ions means the same thing, because hydrogen ion has lost the electron and now it possesses only one single proton. Neutralization. So basically now this you can see here HCl. HCl is a very strong acid. Okay, this is in our stomach also. So when you take HCl and dissolve into water, this can lose hydrogen ions. Okay, so hydrogen ions or the protons from this HCl can donate hydrogen ions, and when it donates hydrogen ions, they combine with this water and forms this kind of a ion. It's called hydronium ion, and chloride will be of course separate. So this is an acid. Now what is a base? Now ammonia is a base. Now why it's a base? Because when you dissolve ammonia into water, it can accept hydrogen ions and forms this kind of a ammonium ion. So this ammonia is a base because it can accept hydrogen ions. So it becomes like this. It's now a ammonium ion, and this water and resulting with that, because this has now accepted the hydrogen ions, this water will be converted into hydroxide ions. So we can also say there's another definition of base, is that base is the one which is the donor of hydroxide ions. OH ions are called hydroxide ions. So we can also call a base is that substance which donates hydroxide ions and accepts the hydrogen ions. And if you take the ions which were created by the acid and base, so this is a hydronium ion which was created here, and this is the hydroxide ion which is created here. If you combine these, they are going to form water, and this is called a neutralization reaction. So this and this, when they combine with each other, they form two molecules of water, and this is called neutralization reaction. So that is why if you mix acids and bases, they neutralize each other. Now what is a strong acid and what is a weak acid? Now strong acid is an acid which will ionize completely in water. So if you take a strong acid and you add into water, it is going to ionize completely. Now what do you mean by ionize? Ionize means it's going to break down. It's going to break down completely. And when an acid breaks down, what does it gives? Acid is a hydrogen ion or a proton donor. So when the strong acid breaks down or ionizes in water, it gives hydrogen ions. So example of strong acid is nitric acid, sulfuric acid, or the hydrochloric acid. Now what are weak acids? Weak acids are the ones which are going to be only partially ionized in water. So if you take a weak acid and add into water, it's going to be partially ionized, which means it's going to be partially broken in the water. And the example is acetic acid. Vinegar is diluted acetic acid, so it's example of a weak acid. Now the strong bases are the ones which are going to completely ionize water, and they are going to give hydroxide ions. Example is sodium hydroxide. So if you take sodium hydroxide, add into water, it's going to ionize completely, it's going to break down completely, and it's going to give hydroxide ions, or other way to say is it's going to accept the hydrogen ions. And weak bases are the ones which are going to partially ionize in water. The example is ammonia and magnesium hydroxide. Now the strength of an acid or base is usually expressed in terms of range of values called a pH scale. Okay, if you have to tell somebody this is an acid, okay, now if you have 2-3 acids, how are you going to say which acid is strong or which acid is weak? Or even if you have 2 acids and both of them are strong, which one is stronger of the two? Or on the other hand, if you have bases, out of the bases, which is a stronger base, which is a weaker base? To describe all these things, to tell the strength of an acid or bases, you can tell in terms of pH values. Now what is a pH value means? P means power, H means hydrogen. So pH means the power of hydrogen. So you tell any acid or base is a weak or a strong on the basis of the concentration of the hydrogen ions that solution is having, that acid or base is having. So that is the power of hydrogen. So any solution, how many hydrogen ions that solution has, tells its pH. And pH tells us the strength of the acid or the base. Now there is a mathematical formula to find the pH. pH is the negative log of the hydrogen ion concentration. So if we have to find the pH of any substance or any solution, we need to know the hydrogen ions in that, and then we can take the negative log of those concentrations. So the key thing to remember here is how much acidic or how much basic any solution is. It depends on the hydrogen ions concentration or the concentration of the protons, because hydrogen ions or the protons means the same thing. So if you know how many hydrogen ions are there in a solution, you know the pH of the solution. Okay, so solution like water has hydrogen ions of the concentration of 10 to the power minus 7. Okay, so in water the hydrogen ions concentration is 10 to the minus 7. So its pH is 7. So water is neutral. Any solution, okay, any solution which has hydrogen ions more than 10 to the power minus 7, that solution will be acidic. So 10 to the power minus 7. So it means that all these solutions which have 10 to the power minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, they are all acidic. So remember that we are now talking in terms of negative values. Okay, so in terms of negative values, minus 6 is bigger than minus 7, because we are talking in terms of negative values. So minus 6 is bigger than minus 7. Minus 5 is bigger than minus 6. Minus 4 is bigger than minus 5. Minus 4 minus 3 is bigger than minus 4. So as we are going this side, we are increasing in the value. If 10 to the power minus 7 is the concentration of hydrogen ions in water, its pH is 7, because if you plug this value in the formula, you get this value. So this solution is neutral. So any solution which has hydrogen ions concentration more than 10 to the power minus 7, that solution is acidic. So any solution which has all these values of hydrogen ions concentration, that solution is acidic. And all these solutions which have concentration of the concentration of hydrogen ions less than minus 7, which will be on this side. So minus 8 is lesser than minus 7. Minus 9 is even less. So in this side, when we go this side, we are decreasing in the hydrogen ions concentration. So all these solutions are basic in nature. So the key thing to remember here is, if any solution has hydrogen ions 10 to the power minus 7, it is neutral. Any solution which has hydrogen ion concentration more than minus 7, that is acid. If any solution which has hydrogen ions concentration less than minus 7, it is basic. So going this side, we are increasing in hydrogen ions concentration. So all these solutions are acidic. And on this side, we are decreasing in the hydrogen ions concentration. So all these solutions are basic. So you can see here, this is the pH scale, and these are a lot of things which we use in our daily life, like your lemon juice. Its pH is around, it's acidic, it's sour in taste. So its pH is around 2.2 to 2.4. Then our gastric juice, which has HCl, its pH range is 1.6 to 1.8. It's quite strong acid. Okay, so the acid in our stomach is quite acidic and helps in the digestion. Vinegar 2.4 to 3.4. Then the carbonated soft drinks we drink all the time, 2 to 4. Then oranges 3.2 to 3.6. Tomatoes 4.2 to 4.4. So all these solutions above this pure water, okay, water is neutral. All these solutions above water here, they're all acidic. And all the solutions down water here, which has a pH higher than 7, like your blood is like 7.4. It's near, blood has 7.4 pH. It is near neutral. It's not acidic or basic, it's near neutral. So the milk of magnesia 10.5, it's basic. Ammonia, which we use for cleaning, 11.9, is quite basic. Sodium hydroxide 13, very strong base. So this is basically the lecture on acids and bases. So we have these slides, and I'm going to talk in the second part of this lecture, which is 3B, which is on the cell theory. And so for this week, we are talking about acids and bases and also about the cells, and we will be also talking about how those cells divide and why do they divide. So for the assignment, it's your own choice out of all these topics. So you can write on acids around you, you can write on bases around you, and you can even write about why the cells what is the significance of the cell division. Okay, so it will be your own choice, but you have to choose only one topic. Okay, so that's your lecture 3A.